Swayam Prabha. Digital India. Educated India.
Okay, today we will be looking at industrial applications of robotics. What we have been studying in the last couple of classes is essentially we started off with kinematics, we had transformations, then kinematics, then we have trajectory planning, and then we had control systems. Now we are looking at essential applications of robotics in industries, where robots are essentially used in industries. Now we should be careful where we are using robots, because robots cannot be used everywhere. Okay, unlike the very common way of thinking is that robots can be used in all kinds of applications to do all kinds of tasks, but that is not true. Now, so we will have to essentially look at where robots can be used and specifically why they are used in a particular industry, in a particular application, etc. Okay, so let's start off today with the industrial applications of robots. And if you look at all the industries, there are different kind of industries. We have automobile industry, we have electronics industries, then we have entertainment industry, we have healthcare, we have defense, we have atomic energy. So if you look at all the industrial applications of robotics, I mean industrial robotics, then the current use of robotics is about 75% of robots are used in the automobile industry, that is in the automobile industry for spot welding and spray painting and pick and place and assembly. Then in the electronics assembly, in the electronics industry, for example, all electronics items today, for example, starting with the mobile phones to cameras to laptops to PCs to almost all kinds of electronics where you need to assemble microcontrollers, chips on a motherboard, in such applications robots are used. And so automobiles and electronics industry make up about 75% of industrial robotics applications. Now, the other applications which are there, so what we will be looking at is in automobile and electronics assembly, electronics industry, what type of applications, what type of jobs are essentially using robots. Okay. And also more importantly, the more important question is where not to use robots. So, we are trying to answer where to use robots, and the second question we are trying to look at is where not to use robots. Okay. So, today's class will be focusing on these applications, and then we will look at in specific detail of a couple of more specific applications, for example, robotic welding, spray painting, and if you are using robots, then we have to talk about safety. So, what are the industrial standards for robotic safety? Okay. So, from here what we see is that 75% of robots, industrial robots, are used in automobile and in the electronics assembly. Now, the other 5%, the additional 5% is used in defense applications. Now, defense application is one area where robotics applications are increasing day by day. So, we have right from demining to automated weapon systems to drones to unmanned vehicles to unmanned aerial vehicles, underwater vehicles, etc., etc. So, defense application is one area where robotics application is going up steadily over the years, and this is one area where we are likely to see a very large number of robotics applications in the future also. The other two areas where robots are used, one is space applications. Now, in outer space, obviously human beings cannot go most of the time, for example, in lunar exploration, in Mars exploration, obviously first time the robots are sent. So, essentially we have space applications which take up another 5% of robotic applications, and atomic energy. Now, atomic energy basically means nuclear power. So, this is nuclear power generation. So, in nuclear power, we know that we handle radioactive material, because of which human beings have to be kept at a distance. Human beings have to they cannot go very near to this high radiation materials, because of which either robots are used or telemanipulators are used. So, if you look at the total here, so 75% of robots, the majority of robots are in automobile and electronics assembly, 5% are in defense, another 5% are in space applications, 5% in atomic energy. So, this makes up about 90% of our applications is about here, right. Now, the remaining 10% is non-industrial applications. So, these applications are essentially what we call industrial robotics applications. Okay. So, this 90% is industrial robotics applications. Now, the remaining 10% is non-industrial applications. So, non-industrial application means rehabilitation, healthcare, prosthetics. Then we have the other area which is very common and catching up very fast is social robotics. Okay, social robotics like clones, helpers, etc., etc. Then we have entertainment. We have in entertainment we have pets, we have movies, etc., etc. Here also we have social robotics as an area which is very steadily increasing. Okay. So, essentially industrial robotics is 10% and non-industrial applications of rehabilitation entertainment is the remaining 10%. Now, this is one area. Industrial applications is more or less saturated at the moment and the area which is picking up in terms of new industries, new startups which are coming up are mainly in this area, which are non-industrial applications. Okay. So, in future we are expected to see this number of 10% increase drastically and pick up in the coming future. Now, the other question that we need to answer here is when we are talking about the future of robotics, what is the future of robotics in terms of which applications are we likely to see, what is the research directions, etc., which we will try and touch upon in this talk today. So, in future we talk about general assembly. Now, there is something called assembly where you know that you assemble two different parts and we call it an assembly. For example, when you are assembling a car, then you are putting the tire, you are putting the glass, you are putting the rubber pads, you are putting the seats. So, this is what would come under what we call assembly, right. Now, there is something called general assembly which robots still cannot do. So, we will have to look at what is this business of general assembly where robots actually cannot are still unable to cope up with. Then we have rehabilitation, we have healthcare and personal robotics. Okay. So, the future of robotics is somewhere here and this is a direction in which we are likely to see research. So, most of the research focus is in this direction, then new industries. So, research, new industries and also startups. So, startups are also in this area of rehabilitation, healthcare, then personal robotics, general assembly. So, this is the basic breakup of robotics applications in industry. Now, let us focus a little bit into more detail and try and understand where a robot is used, why it is used and where you should not be using a robot. So, this is a little old data, this is about 2011. So, we are seeing that the number of robots every year have been increasing drastically. Okay. So, this is 2011 data and this is number of thousands of units. So, we are seeing that from 1973 to about 2011 there has been almost a very steep rise of robotics applications worldwide and this is increasing as of today. Okay. And one of the reasons for this is that the cost of labor is coming down, there is an aging population, electronics is becoming smaller, cheaper and it is becoming more affordable. So, the cost of robot is coming down. So, the general trend is if you look at this straight line, this is the direction in which robotics applications per year is increasing and this is continuing even to this day. Now, if you look at country wise which countries are dominating, then this is the data for 2016, almost 2015-16 data, this is 16 data and we see that the country which is implementing the largest number of robotic systems per year is China and this is like almost 80,000 new robotic systems are being added every year. And worldwide China is leading in the application of robotics worldwide, followed by South Korea, North America, Japan, Germany in that order. Okay. But if you look at the gap between here and here, then there is a very large gap here in terms of the rapid industrialization of China in terms of robotics and automation technologies which are being implemented. Now, so this is an interesting graph to show in different countries which direction automation is moving in. Now, this is another interesting graph on the right side which shows the number of AI patents. So, this one actually shows the number of AI patents being filed every year country wise. This is also 2016 data. So, this is 2014 data, little bit old, but this is very interesting. Now, if you look at this number of patents, the graph in which the increase in the number of patents being filed in the area of AI, then this from 2005 to 2014. So, this 2005, this 2014, the graph has been something like this, right. The top one is showing for the US, whereas for China the graph is steadily increasing in this order, right. So, this 2014. So, it is expected, a lot of industry experts tend to claim that if this graph is going to go this way, at some point it is going to overtake the US. So, China is probably going to be the largest user of robotics, and also the the country which is filing the largest number of patents in the area of AI and robotics, machine learning. So, this includes robotics, machine learning, intelligent systems, etc. Okay, all of this combined makes up AI. So, the number of patents which are filed by China is showing a very steep increase over the last couple of years and last decades. So, these two graphs give us the relative importance of automation in different countries and how automation is going. Now, two things are very common here. First, with respect to the number of robots which are being implemented, we see that there is almost a linear increase in the use of robots in this order. So, the number of robotic systems that are going to be implemented is going to increase year by year, and there is no question about that. Now, in terms of countries, the country which is leading this revolution is China. At one time it was Japan, but now it is China which is leading the revolution of robotics in terms of manufacturing number of units and also implementing it in industry. This is another interesting study. This is also about 2014 or 2016, the number of smart factories worldwide that are being implemented. Okay. So, the number of smart factories that are being smart factories would mean factories which are using some kind of AI, some kind of automation, some kind of robotics, and are trying to make it completely autonomous in the form of smart factories. So, the number of smart factories being implemented is also increasing rapidly in different countries, and this is being taken, the largest increase of about 50% is in the US, then Germany, France, UK, Sweden, in that order. So, in this race of smart factories, of automating conventional factories into smart factories or intelligent factories, is led by the US till now, US followed by Germany and France. So, here China is lagging a little bit, but only in robotics applications China is leading in terms of AI and robotics applications. So, this graphs essentially shows us the two parameters. The first is that the country which is leading, and also the steep rise of robotics applications worldwide. So, there is no question of that robotics applications are going to keep increasing in this particular rate. Now, reasons for this is something which we are interested in. One of the reasons for increasing robotics applications is the aging population worldwide. So, we know that the average life expectancy is going up across all countries including India, and also there is in several countries the population of the country is coming down. Okay. Now, that is not happening in China or in India, but in other countries like Japan, South Korea, okay, Thailand and other countries, you can see that the population is aging very fast, and also the population is not increasing. So, there is a very acute shortage of manpower. So, this aging population and low birth rate is causing decline in population of these countries. Okay. So, one of the major reasons for this high amount of automation or implementing robotics is essentially the aging population worldwide, and also low birth rate, which is causing a decline in population. So, countries like Japan, South Korea, they have to implement larger number of robotic systems because they just do not have humans to do this kind of tasks. So, so this is one of the reasons. So, this probably is one of the big reasons of using more number of robotic systems. The other very big reason, even for a country like India today, is that the labor cost versus robot cost, if you look at it. Now, the labor cost is increasing, the cost of labor is increasing because our as the country is progressing, the cost of the salaries of the laborers who are working, or the persons who are working in industry, is going up, whereas the cost of the robot is coming down. So, this is the direction in which the cost of labor is increasing, and this is the direction in which the cost of robots is coming down. So, although this data is a little old, 2000 data, but still this is very much valid. So, this cost is going up like that, whereas this cost is coming down like this. Now, what is the reason for this? Number one cost is that electronics. So, electronics is becoming cheaper. Okay. It is becoming very much cheaper. So, electronics becoming cheaper is meaning that robots are becoming cheaper robots are cheaper, okay, and are becoming modular. Okay. So, these parameters of electronics becoming cheaper and robots becoming modular and becoming cheaper as a whole is enabling industries to implement larger number of robotic systems, and also the cost of labor is going up. Okay. So, there is no other way for industries to survive unless they can automate. So, the general tendency of industries today, or the belief, is that either you automate or you evaporate. So, either if you do not automate, it will be very, very difficult to compete with other industries. So, very, very good example of this is our retail, okay, retail market, for example, Amazon. So, about 90% of Amazon's applications are automated. So, they are using robots for warehouse management. They are using robots for robots mean physical robots. There are two kinds of robots. One is the physical robot, and the other is the soft part of it, which we call a bot. So, they are using both. So, they are using the software. When you place an order, it is maintained online. The material is retrieved by a robot from the warehouse and it is shipped on to you. So, the full process is 90% automated, and this is also an application where robotics is entering into areas which are not strictly industrial, but also things like retail, rehabilitation, healthcare, helpers, etc., etc. So, two of the reasons why robots are increasing and will continue to increase. First is aging population worldwide, and this is applicable even to India today, and cost of labor is going up, whereas the cost of the robot is coming down. So, industries are left with no other alternative, but they will have to automate. Okay. Now, there is a very steady rise of non-industrial robotics in the last couple of years. So, what we are talking about is, as I said in the beginning of the lecture today, that we have industrial robotics, which consists of automobiles, electronics industry, defense, space, atomic energy, that is industrial robotics. And there is another segment which is called non-industrial robotics. Now, there is a very steady rise of non-industrial robotics applications. Now, what are these non-industrial robotics applications? They are not conventionally manufacturing applications, but applications like underwater applications, cleaning. Okay, cleaning, for example, an automatic vacuum cleaner, that is also a robot today. Then we have defense, rescues, construction, demolition is another area, field robotics, then field robotics, for example, in agriculture. Then we have mobile robotics platforms, medical, logistics, others. Logistics would be things like Amazon. Okay, so this is like Amazon, etc., and all others. So, majority among them, or number one is agriculture is one. Agriculture is one area where large number of robots are being applied at the moment. Home applications, retail. Okay. So, these are areas in which robots were not conventionally there or traditionally there, but robots are picking up at a very, very fast rate now. So, agriculture, home applications, retail, logistics, entertainment is another one. Entertainment would mean pets, movies, etc. Okay. So, these are non-industrial applications where new industries are coming up. So, non-industrial applications are leading to new industries in robotics which are coming up, which are not standard conventional mechanical robotic systems. So, let us move further. Now, these are two areas in non-industrial applications. We have service robots and entertainment robots, which have seen the largest rise over the last 2 decades. So, in the last 2 decades, these two areas have really taken over. One is service robots. Service robots, for example, vacuum cleaners. Even in India, we have the automated vacuum cleaner today. Eureka Forbes has an automated robotic vacuum cleaner, which can clean the room in a particular specified at a particular time every day, and can have ANA's intelligent kind of sensing. For example, it can map its own environment. It can ensure that it has an optimal path, so that it can clean the room, full room, in a particular time sequence every day. So, automated vacuum cleaners, we have this in India today. Automatic lawn mowers, so mowing grass, it can automatically mow the grass. Now, what these robots require is, they require some amount of intelligence. For example, if when it is cleaning the room, it should have a path which is optimally cleaning all points of the room, for which it has to build a map, it has to remember the map, it has to have some kind of a path plan. So, these kind of robots are what come under service robots. Entertainment robots are another type of robots which are picking up very, very quickly today. So, we have different kind of pets, we have movies, Okay. We have helpers, okay. We also have companions, okay, which come under this area of entertainment and leisure robots and leisure robotics. So, apart from industrial robotics, we have non-industrial robotics, which is a very big business these days, and most of the new companies, startups are in this direction. And in non-industrial robotics, the two areas which are picking up very, very quickly, one is service and the other is entertainment, and service and entertainment are these two areas. Now, let us try to answer the most important question for anybody in the area of robotics is, where would you use a robot and where would you not use a robot? Okay. So, this is a question that most industrial people or even non-industrial people have to answer. If you are going to buy a robot, is the robot useful for you or is it not useful for you? And so, let us try and answer this question from the point of manufacturing point of view, manufacturing industry. So, as far as the manufacturing industry is considered, okay, manufacturing industry would mean any kind of industry which manufactures something, ranging from automobiles to parts to electronics to even retail like Amazon. So, these are industries which are producing goods or selling goods. Now, we know that this graph, you would be familiar with this graph, that we can draw this graph or we can position different manufacturing tasks in this graph, which in the x axis there is production quantity and on the y axis we have production variety. Okay. So, all manufacturing processes can be clubbed into this graph, and this graph essentially is product quantity versus product variety. For example, let us look at a car. So, if you are looking at a car, for example, Tata Motors is making a car. Okay. So, the number of cars that it is going to produce will be very, very large. So, Tata Motors will not make say maybe 10 cars or 12 cars of one type. So, they will be making cars in lakhs or thousands. Okay. So, the quantity of this car is going to be very, very large. So, on the x axis we have production quantity. So, for cars it is somewhere here. So, automobile companies will be making very large number of a particular type of car. Okay. And the product variety, for example, the different types of cars would be very, very low. So, it will be somewhere around here. So, for example, they make only about 5 or let us say 15 type of cars. Okay. Say for example, Tata Motors is making an Indica car or an Indigo car. Okay. So, they will be making maybe 1 lakh of Indigo cars, they will be making maybe 1 lakh of some other kind of car, another 1 lakh. So, the total product variety of cars would be very, very low. So, it will be about 15 or maybe 5 or 15, which is very low compared to this number, which is 1 lakh or more, right. So, this kind of production would come under what we call mass production here. Now, on the other side of the graph is companies which make parts which are very, very specialized. For example, a company is making a particular part for a turbine application or for a particular application where the product variety, they make different kind of parts, but very low number of parts. So, for example, here if a company makes only 10 numbers of a particular component, okay, but they make different. So, the total number of components is only 10, but the variety of the number of components is very, very large, say it is about 100 or more, 100 or more. So, they make only 10 number of each part, but they make different types of these parts, about 100 or 200 of these parts. So, that kind of production would come under here, what we call job shop production. So, whole production or manufacturing industry is classified in this graph as being mass production or job shop production. In mass production we have very large numbers, product variety is very small, whereas in job shop production we have very large variety, but very, very low numbers. Now, in between this job shop and mass production, we have another kind of production which comes in here, which is called batch manufacturing, okay, or sometimes called cellular manufacturing. Now, in this particular case, your production quantity will be about say 10,000, okay, which is not in lakhs, but it is say 10,000, 20,000, and your production variety would be say about 50, just for an example, say 20 or 50. Okay. So, this type of manufacturing comes somewhere in between, okay, where the production variety is not very high, but there is variety in the product, and then total number of production is also high, it is about 10, 20,000, but it is not in the lakhs. Okay. So, this comes somewhere in between, called batch production. Okay. Now, the question comes, we can fit in all kinds of applications in manufacturing industry, all industrial applications into this graph. So, now where in this graph can we use robots? The question we are trying to ask is robots or should be used, okay. Say where. So, the question we are trying to ask is this one, where robots should be used in this graph, okay, where, either in job shop or in mass or in thing or everywhere, okay. Now, if you think a little bit, it would appear that you want to use robots everywhere, okay. Why? Because robots will automate the process, make it faster, etc., etc. But we need to remember that a robot essentially is programmed to do a very large number of applications, a very large number of tasks autonomously. For example, if it is doing pick and place, it's picking an object from here and keeping it here, okay. But it will do that task, but it will do it very large number of times, okay. So, nobody will use a robot for picking up an object and keeping it here one time. Why? Because the cost of the robot is high, and also to make the robot do this task, you have to program it. So, if you have to keep changing the task, you have to keep changing the program. Now, programming a robot is very, very expensive, because there are specialized companies which do this programming, and they have to do the programming, then you have to do the testing, you have to do the validation, and only then it can be used, which takes a lot of time. So, if you are going to pick up one task, one part and put it somewhere else only one time, nobody is going to use a robot. It is not going to be economically viable. On the other side here, if you are looking at a very large number of parts in mass production, say you are going to produce 10 lakh cars. Now, there also if you are using a robot, it does not make much sense, because you are doing the same task 10 lakh times, but there is no change in the task, okay. For example, if it is picking up an object, putting it somewhere in a mass production system in an automobile assembly line, okay, then also it does not make much sense, because there are easier ways of doing the task. For example, pick and place can be done by hard automation devices. Hard automation devices are things like transfer lines, pick and place applications, pick and place, but not a robot. So, if you do not want to change there is no change of task, okay, then also robot is not viable, okay. Why? Because why would you buy a robot if you do not need to reprogram it, or you do not need to change the program? There are easier ways of doing this task by using hard automation. So, robots are not used here, okay, in job shop, because every time the product variety changes, your task will change and the robot program has to be changed. So, it is not economically viable. Again, on the other extreme of this graph is mass production, where again robots are not used everywhere, because there is no change of the task. You are doing something 10 lakh times or 20 lakh times, there is no change. So, why use a robot? Use a hard automation device which is cheaper, okay. So, whereas here in automobile industry, there are some applications where robots are used, okay. So, there are some applications where robots are used. So, applications like spot welding, spray painting, and simple pick and place, some assembly in the mass production system where robots are used, but not everywhere. Now, the other point is that where robots cannot be used, okay. For example, there are some applications where robots cannot be used, and that is applications of what we call general assembly. So, today we will also be looking at applications where robot just cannot do this task. So, what kind of task a robot cannot do is something that we will look at, and that comes under what we call general assembly. So, as far as this graph is considered, the point where robots are used is here. So, this is the area in which robots are used, and where robots are economically viable. Why? Because the number of parts is not very large. So, making hard automation is not viable. As soon as the part changes, you have to change your hard automation. That is not going to make it viable again. So, somewhere here robots are used for in terms of the industrial production processes. Now, what are this type of processes called? They are basically called flexible automation. So, flexible automation, we also call it programmable automation. So, this is the area in which robots are basically used, okay. So, programmable automation, flexible automation comes into this region, and this is where robots are used. They are most economically viable in this region, okay. And flexible automation also can be of different kinds. We can have flexible manufacturing cell. For example, we have a robot, we have machine tool, we have parts carousel, we have parts, so part handling, okay. So, this is the area where robots are most feasible, and feasible in terms of economic viability, okay. So, we can have a flexible manufacturing cell, and we can also have a flexible manufacturing system. So, this is something very, very important to remember, that when we are talking about industrial processes and you are thinking of using a robot in a particular industry, you have to first fit your industry in this graph and say that where does my industry fit. Does it come under mass, does it come under job shop, does it come under job or batch production, and then you can talk about can a robot be used there. And after that, we need to also look at the concept that the particular task, can the robot do the task or not. Okay. So, the first part we have handled, we have seen that robots can be used in this section. Okay. So, robots can be used here effectively, economically they are viable. So, economically viable here in this region, okay, in this region only. And the second part is even in this part there are some tasks which a robot cannot do. So, we will also look at tasks which a robot cannot do and why it cannot do. So, flexible manufacturing or programmable automation can be divided into flexible manufacturing as well as flexible manufacturing systems. They come under the same. Now, when we are using a robot in an industry, basically we have to look at the design of the physical layout of the equipment, okay, and the physical layout would mean how are you going to position the machines. Okay. So, what are the machines in a normal manufacturing system? We are going to have a machine tool. So, it can be a lathe machine, it can be a lathe, it can be a mill, it can be drill. Okay. So, some machine tool, they can be so these are machine tools or machines for doing a particular task. Then we have parts, part handling, parts carousels, where the part is coming, where it is going. The robot picks up a part from here, keeps it there, and then from there it puts it there. So, a robotic workstation would basically consist of robots. They will be consisting of machine tools, parts arrival, carousels, and they can be a part carousel, they can be conveyors. Okay. So, all of this together makes up a manufacturing system, and so the physical layout of this manufacturing system is to be thought about before we are going to design the robot work cell. Now, the design of the physical layout consists of the physical placement of the machines. Now, when we are doing that, we also have to talk about, we have to think in terms of the coordination and control of the different pieces of equipment. For example, a robot is going to communicate with other machines. For example, we have a robot here. This robot is going to pick up a part from here and keep it there, and after it has done the machining, maybe it will take it and keep it there. After this has done the machining, maybe it will take it and do inspection there, okay, just for example. So, the robot has to access this, when to pick up a part from here, put it there, then take it and put it somewhere else, etc., etc. Okay. So, all this region, all this machine should be accessible to the robot. So, and apart from the accessibility, it should also be able to communicate. For example, if a part has come, the conveyor should be able to tell the robotic cell that the part has come. So, there has to be some kind of communication. So, number one is accessibility, and number two is communication. Okay. So, these are two aspects on robotic work cell design that are required: accessibility of the parts and communication between the systems. And there are three types of robot cell layout design. So, in terms of the physical layout of the robotic cell, there are three kinds: robot centered cell, inline robot cell, and mobile robot cell. So, what do we have here? The first type is the robot centered cell, in which we have a robot in the center and you have the machine tools which are surrounding the robot. Okay. So, this as the name explains, or the name means, is that the equipment is in a circle around the robot, and hence it is called a robot centered cell. So, the robot is in the center of the cell, and the kind of industrial applications that are used, kind of industrial applications that use this kind of robot centered cell are die casting, arc welding, then spot welding, okay, assembly. Okay. So, this kind of applications are normally using a robot centered cell, where the robot is in the center and the work tables are all around the robot, and this is probably the most commonly used, okay, because welding, spot welding, assembly, electronic assembly is about 75% of all industrial applications. The other type is, the second type is inline robot cell, where you have a number of robots and then you have a conveyor which is bringing a part. Okay. For example, the automobile industry. So, automobile industry uses this kind of cell. So, so we have a car. So, for example, we have a car which is the car body comes and sits here, and it comes and stops on a particular station. The robot will do some tasks on the car, then the car will move to the next station, some other robot will do something else onto the car, and this is the way it goes. So, we have transfer lines. So, here we have transfer lines or conveyors, where the robot will be doing something in one particular station. So, this again, as the name implies, is an inline transfer cell, where the part is moving in a line and the robots are also positioned in straight lines. The third type is mobile robotic cell, in which the robot moves. In the previous two cases, if you note, the robot is not moving. So, the base of the robot base is fixed. So, the robot does not move, it is a fixed robot. In the second case also, these fellows are fixed based. Okay. Now, whereas in the third case, the robot has a moving base. So, here we have the moving base, and the robot is moving from one point to another point, doing a particular task here, then it comes back and does another task. Now, this is as the name implies, is called a mobile robot cell, because the robot is mobile. Now, in many industrial applications, this is not allowed, for the simple reason that this, as far as industrial applications or safety is considered, the robot and the human have to be in different work areas, and if the robot starts moving, if the base of the robot starts moving, then it can interfere with humans also, which are in the side. So, as far as industrial applications are considered, this is very rare. So, this is a very rare application, essentially from human safety point of view. Okay. From human safety point of view, this is very rare, because if the robot is moving around, the robot base is also moving, it can start interfering with the humans which are around in the same environment. Three areas, three types of design: robot centered cell, inline robot cell, and mobile robot cell. Now, we are interested in looking at the future of robotics. We have said that as of today, 75% robotics is used in automobile, electronics, etc., etc. Now, what about the future? Where is the future of industrial robotics? Now, the future of industrial robotics is one is in general assembly. Okay. So, we need to look at what is general assembly. Cellular robotics is where there are different modular robotics which are doing tasks by themselves or in cooperation. For example, in this particular application, there is one robot only here. So, there is one robot and there are machine cells. Whereas, in cellular kind of environment, there are many robots. Okay. So, there are many robots which are organized in cells, and each one helps the other one to do a particular task. Then we have multi-agent systems, where we can have a very large number of robots, or we can have different types of robots. Okay. For example, we can have a robotic arm, we can have a mobile robot, and all of them are cooperating. Then we have space, underwater, unmanned aerial vehicles. Vehicles is our unmanned cars. Okay, unmanned cars. So, this our unmanned cars or driverless cars. So, driverless cars would be in the area of. So, this is one area which is very important now, and lot of car companies are actually looking to make driverless cars. So, driverless cars in a way are robots, and so this is one area. Surgical robotics is another one. Surgical robotics, then rehabilitation robotics, then safety in robot human cooperation. So, this is something which we will look at, why safety is so important and how does it govern. So, how does safety actually govern this full industrial applications of robotics, and we will see that as of today, robot and a human have to stay in different workspaces. So, they cannot be in the same workspace, and that is what makes the industrial task a little bit difficult, because the robot and the human are in different spaces. So, if you want to do a particular task, then the robot will first do the task, then give it to the human. Or the human will do the task and then give it to the robot. They will not work together. So, if you want to bring them together, then this is a new area called robot human cooperation or robot human interaction. Okay. And such robots are requiring new kind of robot designs. So, new robot designs are required, which will make them safe essentially. So, for example, if a robot hits a human, then the robot should not be damaged or the human should not be hurt. So, that will mean some kind of new design. So, current industrial robotics, we cannot have a robot and a human together, because this hard in the industrial robots, if it hits a human, then the human will be injured very badly. Then we have bio inspired robotics, okay, robots which are inspired from biology. Then we have a new a completely new area in future called ethics, laws for robotics. As of today, we do not have industrial robotics laws for robots which are working in industries. For example, if there is a robot which is working in an industry and there is an accident, then who is responsible? The human who caused the accident, or the robot is responsible, and who pays for the damages? So industrial laws for robotics is still not there. We have industrial laws for normal industries, for humans working in industries, but for robots we don't have. Now ethics is another area. What should robots do and what they should not do? Say for example, in the area of what they should do and should do or not do. For example, in the area of unmanned weapons. So this is an area of unmanned weapons where weapons are being robotic weapons which are being fired by a robot. So is it possible for the robot to decide when to fire the weapon, or it is the human who is going to decide? So this is an area of ethics, that in a robot human interaction, okay, should the human always be in control, or the robot should be in control at some point? So these are areas which are very new, which are coming up, and which are likely to be very, very active in the next couple of decades and in future. Okay. So let us look at them slowly and one by one. So these are some of the areas. So from mobile robots to humanoids. So we had initial applications of mobile robots where we had one mobile robot which having a differential drive, 3 wheels or 4 wheels, and it was moving around, for example, an AGV. Now from this AGV, so from an unmanned guided vehicle, AGV, which is used in industrial applications, if we mount a humanoid robot on top, we end up with something like this. So this robot not only can move around, it can do particular kind of tasks also. So we have example here. This is also an example of a 2-arm robot which is mounted on a mobile base. Then robot human cooperation. So we have a human on one side and we have a robot on the other side, for example, carrying an object together. So can the robot and the human would be doing this task together. Now this is another application on the right side, this one which is showing the person who is being guided, who is sitting on the robot, and the robot is moving around maybe. Okay. So there is a robot, there is a human, and there is some kind of cooperation between them. So the question we were talking about here is if there is a robot human, who should be a leader and who should be a follower? Should the human always be the leader? So what is the ethics of that and what are the laws? As of today, there are no laws. The only ethics and the which is presently being followed in industries is that the human should always be the leader and there should be a human in the loop. So for example, for an autonomous weapon, the weapon cannot fire by itself. There always has to be a human who is actually going to do the firing. Rehabilitation, for example, help in carrying loads, enabling persons to walk, for example, people having very weak muscles, old elderly people or people who are suffering from some disease. So for such people, if they can have a robot which is a wearable robot, and this wearable robot will provide strength to the person's legs or hands to enable the person to go upstairs or come downstairs or to carry a load. So this is an application in rehabilitation. These are also called exoskeletons. So these are also called exoskeleton kind of robots, which are wearable robots, and they enable the person to enhance their physical capability. So exoskeletons for enhanced physical capabilities. Okay, so these are basically called exoskeletons. Then we have exoskeletons which can help the person in rehabilitation, for example, walking. So this is a person who is paralytic and cannot walk. So to help this person to walk or to help the person train to walk. So these are robots which are fitted onto the legs, and it enables the person to learn how to walk again. These are for physically disabled people, for example, feeding a person. This is a robotic feeding system. So this one is a robotic feeding system. So the person can be fed by a robot. So the robot takes the spoon and takes the food and puts it into his mouth, a person who is disabled. So these are some of the applications, robots in construction. So autonomous construction equipment. So you must have seen a lot of this operating on the roadside, where there is a human being who is sitting and doing the task, sitting and actually controlling this machinery. So there are a lot of companies which are actually working on making this automated. So there is no human being, but it is controlled through teleoperation. So the person is sitting somewhere else, and the person can very easily control the device sitting at a distance. Then robotic vehicles, we talked about driverless cars. So, driverless cars, okay, this is a very big focus area today of having having cars which are autonomous, which can move around with, which can go in traffic from one point to another point intelligently, and you don't need a driver there. So, automatic robotic vehicles, also called driverless cars. Now, having driverless cars is also the other area which has come up, is automatic road tracking. So, if you want to drive without a driver, then what are the traffic rules you should follow? How should you drive on the road? For example, automatic road tracking is one of them. So, this is a software which basically looks at the lines on the road, and it can follow the two lines and keeps the lane. So, this is for lane tracking. Okay. So, this is a automatic car which is following a particular lane, okay, simply by looking at the white lines, whereas the one on the right side is basically looking at obstacles. Okay. Again, it is driverless and it is looking at obstacles. So, if there is another car in front, then what distance should we maintain? Should it overtake? Should it allow the car to go through? If there is a pedestrian, should it stop? So, driverless cars have to take into consideration all these parameters. So, automatic road tracking, driver tracking. So, a lot of cars today have these features already inbuilt. So, driverless tracking is if a driver is not paying attention, if the driver is falling asleep, for example, if the driver is sleeping, okay, or is looking elsewhere, okay, then it can be alerted. So, there can be some kind of an alarm that the driver is not paying attention to the road or is looking somewhere else, maybe looking at the phone. Okay. So, driver tracking is another area where people are looking at lot of. So, all these areas, lot of the companies are actively working in these areas, because this is the future of robotics. Surgical robotics, where a surgeon is operating. So, for example, we are looking at this, this is the master station, and this is the slave station, where the person is sitting somewhere else and is simply looking into a TV monitor or in a 3D kind of environment and is operating. Now, this operation can be taking place at a distant location, or it can be in the same location. The doctor could be sitting somewhere else. Now, the advantages of this being that they are very precise. For example, what you must be knowing is that the human hand shakes with a very small amount. So, if you are trying to do very minor delicate surgery where you have to cut in very small amounts, then it is very difficult for the surgeon, okay, and he can make a mistake. Whereas, for a robot, the robot can be very precise, and also the robot has a very large degrees of freedom. So, it can be very accurate as to where it is going, and the doctor can operate from somewhere else. So, surgical robotics, social robotics, where there is a lot of robots which are coming into society in the form of social robotics, and social robotics is in society, helpers, we have clones, okay. Then we have all kinds of other androids, cyborgs, etc., which are coming into society today, and these are robots which are made to help as helpers. Now, again, this is basically coming in because there are a lot of countries where there is no manpower. For example, in an airport, to have an assistant or a guide. Okay. So, it is difficult to have a manpower, a person sitting there and doing the task. So, they would put a robot which can do exactly the same task. Okay. And these are very interesting topics, because the questions of, if you are having a robot to interact with a human, then what should be the shape of the robot, what should be the feature of the robot, what should be the voice of the robot, should the robot be intelligent, these questions come up. So, social robotics is a very big area today, and it is also combining with things like AI, machine learning, machine intelligence, and behavioral science, etc. Okay. So, this is another area. Pets and helpers. So, these are some of the robots which have been made by several companies which are being sold today worldwide. So, the Sony dog. So, there was a Sony dog which behaves like a real dog, and these are pets for this is for patients and also for children. Okay. For example, dyslexic children or autistic children, they find it more interesting to interact with this kind of pets which have some kind of intelligence for interacting with humans. So, pets is the other. Learning skills, this is machine learning. How can a robot behave like a human? Then we have brain computer interface. So, in brain computer interfaces, for example, can we take the brain signal right from here and then control a robot. So, today if you are playing a video game, you are normally on your mobile phone or on the computer, then your input is basically from a joystick. So, for example, you are using a joystick to move the car or to move a device or to move a part on your screen, or you are simply typing with the keyboard. Okay. So, your input is basically using a keyboard or by using touch screen or by using a joystick. Whereas, if I can take the input straight from the brain and then actuate the robot, then we have what is called a brain computer interface. So, this is supposed to be the future of interaction, future of human machine interaction. And this is so because simply by thinking you should be able to do a particular task. So, when you are thinking of something, the machine, it can be a computer, it can be a video game, it can be a robot, it should be able to figure out what you are thinking, and based on that it should be able to control the device. Some devices are already available in the form of very simple gaming. For example, in this in the racing game, some of you might be familiar with, you can put 2 electrodes in your head, okay, and simply by thinking left right you can control the car in a race game. Okay. But it is for very gross kind of motion, gross type of motion is possible. By gross I mean what I mean is like large movements, large movement of hands, legs is possible to detect, but for very fine motions, very fine kind of thought is still not possible to detect using brain signals. Now, ethics laws, we talked about industrial laws for industrial robots as well as social robots. So, this is an area which is very new now, but is coming up and is likely to become very, very strong in the next couple of years. Now, let us look at this topic of general assembly. We said that in assembly applications, by assembly I mean putting 2 parts together or doing a particular task. Now, a lot of these assembly applications as of today is not fully automated. For example, if you go to any car manufacturing company, for example, if you go to Tata Motors or Maruti or any other company, even the best companies in the world, what you will find is that there are some robots which are doing something, there are some automatic processes like transfer lines, but there are also humans which are involved in the task. Okay. So, automobile manufacture as of today is about 80% automated, okay, but the remaining 20% is still a human. Humans are there to do this to do this remaining 20% of the task. So, the question is, why human beings are still required? Is it that the company wants to have human beings, or is it because human beings still are required to do particular tasks because those tasks cannot be done by robots? So, here we are trying to ask the question that what tasks robots cannot do. Okay. So, this is what we are trying to do, trying to ask here, and this is what comes under what we call general assembly. Okay. So, about 80% of tasks are automated, but 20% is still remaining which human beings are required to do. So, this 20% of tasks is what we call general assembly, and the future of robotic assembly is going to become general assembly. Why, as of today this general assembly tasks cannot be done by robots. So, industries are trying to develop robots which can do this general assembly kind of tasks. So, what is general assembly? Now, if you think a little bit here, what kind of tasks a robot cannot do? First, we said that in industrial applications a robot is best suited for processes which come under batch production processes, right. But in batch production also, or in any other kind of production or assembly, what tasks a robot cannot do? Now, whatever you have studied till now in terms of kinematics, then dynamics, we looked at control system, trajectory planning, etc., programming. Now, especially in programming, if you think from the point of view of robot programming, let us look at it from this direction. So, we looked at robot programming in Val2 language which we learnt. Now, in Val2 we said that there are basic commands. The basic commands are points in space, say P1, P2, P3, where we give the coordinates, and then there is a move command, okay, move or moves, and then there is open close of the gripper. Okay. So, these are the basic commands for a robot. Now, if this is the basic commands of the robot, then all tasks must be performed, or you should be able to encode the task using these commands only. Okay. Now, if you cannot do that, then it basically means that you can't do the task, or the robot cannot do the task. So, are there tasks where it is very difficult to write these commands? Okay. Now, if you think a little bit, you will be able to understand that whatever we have studied so far, that these are tasks where it is very difficult to do to write in this form. Now, for example, parts which are deformable, rubber, cloth. Okay. So, if you have a rubber, let's talk about a rubber band like this. Okay. If I define points P1, P2, P3, so this is my point P1, P2 and P3. Okay. These are coordinates, position, orientations in space and time. Now, suppose this is a rubber parts and I catch the rubber part using a robotic gripper here. Okay. So, this is a robotic gripper which is catching this one and is trying to lift it. The moment it tries to lift it, because it is rubber, this is going to deform like this. Okay. The moment it deforms, what will happen? This point is no more here, this point has moved somewhere else. Okay. So, what would happen is, if you cannot specify these points in space and there is deformations, okay, in case of rubber and cloth or some kind of deformable material, then the robot will not be able to manipulate it. Why? Because these points are not fixed in space anymore. Okay. So, parts that are deformable, parts which are made with rubber, with cloth, etc., or soft material like foam, a robot will find it extremely difficult to handle. Okay. The other kind of deformable material parts are thin sheets, okay, sheet metal. So, a robot would find it very difficult to hold these things, because the moment it tries to catch, it is going to deform and the coordinates in space are going to change. So, if you go to any car company today, you would find that there are human beings which are doing something. And what are these human beings doing? Number one, they are putting the cars in the car, they are putting the tires, okay, they are mounting the wheel, and after they mount the wheel, they position the four bolts properly on the wheel. Then they put a nut, and after putting the nut, they are going to tighten the nut. Okay. And this task is done by a human being only, because it is extremely difficult to tighten a nut, to place a nut correctly on a bolt by a machine. Okay. A robot would find it very, very difficult. If you think a little bit, when you are trying to put a nut onto a bolt, very often the nut will get jammed. Now, in an assembly line, you know that if a nut gets jammed, then the full assembly line will have to stop. And if a line stops, there is a very, very large delay for the whole system, and that is a very big loss for the company. So, essentially things like nuts and bolts, mounting nuts and bolts, mounting tires. In terms of rubber and cloth, if you look at a car, around the doors of the car, on the chassis there is a rubber seal, okay, that prevents the water from getting inside. Now, how is this rubber seal put? If you go to any car company and see, what you will see is that the person, if this is a rubber seal, so the person will take the rubber seal with his hands, and he is going to fit it onto the car body, and after he fits it, he is going to take his whole hand and press against the whole rubber seal and place it on the car body. So, if I were to draw and say, so this is my car body, just to give an example of what I am trying to say here, is there is this is my car body, and this is the doors. So, there is a rubber seal here. Okay. So, how does the person place the rubber seal? So, he would first fix it with his hands there by pressing it, then he is going to place it across this door and keep pressing with his hands. Okay. So, this is the rubber seal onto the door, and he is pressing it across and fitting the whole seal. So, in any company around the world, if you go, you will find that this is done by a human being. Smooth parts like light bulbs, glass, then fragile parts like glass, these are applications where human beings have to do the task. Now, so the future of robotic assembly is trying to get robots to do this kind of tasks, and also to have robots which can work with human beings together. So, in the present industrial situation, there is a safety barrier between a robot. So, there is a human worker on one side and there is a robot on the other side, and they both are in different work regions. So, if they are in different work regions, they cannot do the work together. So, if they cannot do the work together, it takes more time, and the future of robotic assembly is robots should be able to handle flexible equipment, parts, and also the robot and the human should be working in the same environment together. So, today we will look at a very short video of robot human interaction as to so this is a robotic application where we are having a robot. So, industrial robots basically look like this, which are hard, they cannot work with humans. So, the future of robotic applications is essentially to have robots which can work with humans. So, this is a different kind of a robot, unlike an industrial robot, which can work with humans, and it can learn by itself. Now, work with humans means essentially it should be able to, for example, here it is being, so you can see that the person is actually holding the robot and moving it around. In an industrial robot, we cannot do that, and if it is hitting the person again, the person is not hurt, the robot just moves back. So, this is basically what we call collaborative robots, or the future of robotic assembly is robots of this nature, where the person can actually hold the robot, move it around, and do a particular task. So, today we looked at various applications of industrial applications, and the future of robotic assembly, the future of robotics in industries. So, we stop here today. So, thank you.